This question is asking us using implicit method to do the derivative. Okay, yeah. As we learned this kind of question in summer, if we want to do the derivative of this guy, this is easy. X squared derivative is 2x. Minus 5x derivative is minus 5, right? Yes, this is easy. The second one, the y prime, is we use the chain rule. This guy can be rewrite x squared plus 5 to the power of 1/2. So this equals to 1/2 times x squared plus 5 to the power of 1/2 minus 1, which is negative 1/2. And then we are going to times x squared derivative, which is 2x. This is a chain rule. Here we use a power rule first, then we use this kind of chain rule, okay? Now, not always that we can find out y equals to fx. For example, this one, we won't be able to solve y, right? Yes, so in this situation, we are going to do the derivative for each single term. First term derivative is 2x. Then xy derivative should be equals to what? Can you tell me?
1 times y plus x times dy over dx.
Yeah, you can also write down y prime, okay? Minus y squared derivative is how much?
2y times y prime?
Yes, and equals to 0, okay? That makes sense?
Yes.
Then we can solve this y prime. So x minus 2y times y prime is going to equals negative 2x minus y. So y prime equals to negative 2x minus y divided by x minus 2y, correct? Yes. I think you can handle this kind of question, right? Yeah, we did this same question in summer, correct?
Yeah.
Okay, now let's take a look at that guy, all right? Yeah, this time they are asking you for differentiate with respect to t. Previously, we do the derivative respect to x, you know. Now, this time they ask us to differentiate with respect to t because we are going to learn the relative rates. Relative rates, the variable, the independent variable is not x, it's time. So we want to do the derivative of each term with respect to t. Y cubed derivative respect to t is 3y squared and then dy over dt, right? Yes?
Yes.
Okay. Now, y squared derivative respect to t is 2y times dy over dt, right?
Yes.
And then x squared derivative respect to t is minus 2x times dx over dt. Okay? Then
Okay.
equals how much?
0.
Equals to 0. Okay. Now, dy over dt, we can put 3y squared plus 2y times dy over dt equals to 2x times dx over dt, correct?
Yes.
So dy over dt equals to 2x over 3y squared plus 2y times dx over dt. Okay. Well, this is typical relative rates. They tell you the dx over dt. They want you to calculate the dy over dt. Okay. This is the way to calculate dy over dt when given dx over dt. That makes sense?
Yes.
Okay. Now, this one, B, question B, respect to W, it's going to be the same. Just to change dt to dw, that's it. Okay. That makes sense?
Yes.
Okay. We will have no trouble for this one. I do see that you have some. This one is dy over dx. We can already do it. Let's see this one. Let's see here. If you have a TI 89, no, we use TI Inspire. This is too old. It has an implicit differential command line. It's under F3 to check this one. Type implicit diff. Oh, okay. So let's do this guy. Let's do here. Let's check if TI Inspire. Does TI Inspire have this option? First, let's do this. Okay. Let's find out this guy's second derivative. Let's find out the first derivative. All right.
Okay.
Y squared derivative is 2y times dy over dx. Okay. And then plus x derivative is 1 times y plus x times y derivative, which is dy over dx, equals to 0, right?
Yes.
Now, it's time for us to do the second derivative. When we do the second derivative, we want to use a product rule, okay? 2 times, yeah, you can do your by yourself and then check with my answer, okay?
Okay.
You finish?
Kind of lost on the first step.
This step you get it, right?
Yes.
All right. Now you want to do the product rule for this and for this. Remember during summer when I teach you this part, I say it dy over dx. And this is the first derivative, right? And if you do this guy, d of this guy over dx, this is the second derivative, okay? These are not the same. This is different with dy over dx squared, okay? So when you do the product rule, you do this guy derivative, which is dy over dx, times this guy, plus copy down 2 and y, and then derivative of the first derivative. The derivative of the first derivative is a second order derivative. Okay, so make sure you do here. And then y derivative is dy over dx. And then this guy, you use a product rule one more time. Yeah, you want to rewrite this line, please. You get what I mean?
Yeah.
You need to be able to do this correct by yourself, okay? And remember in summer, you are able to do this, okay? Yeah, you can do this. when you finish doing this, I'm going to show you the power of using our TI Inspire to do this, okay?
Okay.
Are you okay? You want me to go through with you?
I'm on the second to last line.
Okay.
Can you explain what you did on that one?
This line?
The one below it.
This line?
Yes.
Okay. So far we have the same, right?
Yeah.
Okay. So I'm going to do the common denominator. This guy is x plus 2y. This guy is x plus 2y squared. They don't have the same denominator. So I'm going to use this guy as the common denominator. This guy becomes to x plus 2y squared. So I'm going to leave this 2 outside. I'm going to use y times x plus 2y, which is this term. And then minus, because they both have 2, so I take a 2 out and minus 2 times y squared. If you wanted to write down one more extra step to help you better understand, you can do this. X plus 2y squared. Then this is 2 times y times x plus 2y. Okay. Minus 2 times y squared over x plus 2y squared. Does that make sense?
Yeah.
What you did here is you make a square and then you times x plus 2y on the top. Okay. And then what I do is they both have 2, right?
Yes.
So I take a 2 out. Then here becomes the y times x plus 2y. And here is y squared. So I'm going to do this guy inside the parentheses. And then equals, this guy becomes xy plus 2y squared. 2y squared minus y squared becomes to positive y squared. Okay. So this is xy plus y squared. And you have x plus 2y on the left. Then you divide it by this guy. From the left, this becomes to the power 3. Does that make sense?
Yes.
Okay. So when we see here, we can do this. Yeah, based on this guy, we can also do the quotient rule. Let's use the quotient rule to find out this. The second derivative, okay? Second derivative respect to x. This guy is going to be that guy derivative, right? So we are going to use this quotient rule. Quotient rule is saying you do your denominator derivative, denominator square. Remember the quotient rule, that's x plus 2y squared. Then the top one derivative, this top one derivative is negative dy over dx, right? Times 2x plus 2y. And then minus the top one times the bottom one derivative. That's 1 plus 2 times dy over dx. Okay?
Okay.
Yeah, based on this, you can also find the same answer. You can go ahead and find it, okay? Yeah, as long as you can do this question correct, and you shouldn't have any trouble for the test. 我在上课，我在上课，你可以出去吗？
Okay.
You got the same answer?
Yeah.
All right. Now let's see the last question that your teacher gave to you. All right, let's focus on this one.
Wait, is it possible to do it on the calculator?
It's possible for doing the first derivative, the implicit. So you can use your TI Inspire. Let me check because you don't have a TI Inspire CAS. You just have a CX, right?
Yeah.
Yeah. CS is more powerful. CX might not be able to get the second derivative, but the first derivative is possible. You open your calculator, put it in the calculator mode, okay? In the calculator mode, and you click menu, and then calculus. There is the problem is TI Inspire CX does not have that option. Yeah, your calculator don't have that option. Only CAS has the option.
Oh.
Yeah, I don't know if you can see my screen. I can show you here. Can you see my screen?
No.
Here? Let me show you in my camera. So here, you see, they have this one, implicit differentiation, y squared plus xy equals 25 and comma x comma y. Okay. You see here, they have this option. That's why they can do this by calculator, give this answer here. You see? Yeah, but I check CX. You can open your CX. CX doesn't have this option. If you go to calculus, there's no place for you to type in the implicit differentiation. You know?
Yeah.
Yeah, you don't have that option. Only CAS has that option. That's a problem. Yeah.
Oh, it has numerical derivative at a point.
Yeah, they give you the derivative at the point, but not the formula. Derivative at the point is meaning this. For example, they ask you dy over dt at t equals to 1. Okay, yeah. Cx can solve this one, but Cx cannot solve something like this. You know?
Yeah.
At a point means the t equals to a specific value. Okay. Yeah, Cx cannot do this. Only CAS has the option. Yeah, that's a problem.
Okay.
Yeah, now let's move on to this question. Oh, find the dy over dx. Yeah, I believe if they have a test or quiz, they will give this kind of question. This is a very important question. Okay. Same answer, right?
Yeah.
Good. Now let's look at this question. This is something very important. Yeah, at 1, -3, they want you to find the tangent line. Okay. So first, when you see this question over here, you want to see when x equals to 1, okay? When x equals to 1, you want to find out your slope at this point, right? Yes?
Yes.
You want to find the slope at this point. The slope at this point is that guy, you know? Yeah, that's the slope. So your slope at x equals to 1 is 2x over 3y squared plus 2y minus 5. Okay, x equals to 1. Then you don't know your y value, so you plug in x equals to 1 back to this original equation. So y cubed plus y squared minus 5y minus 1 equals to -4, right?
Yes.
Now we are going to move this guy. Hey, hold on. They already tell you -3. They already give you this value. Okay, so we don't need to struggle. This point is given already, which is good. This equals to 2 times 1 is 2. 3 times -3 squared, which is 9. Minus 2 times 3, which is 6. And then minus 5, right?
Yes.
So 27 minus 11, which is 16, right?
Yeah.
That means the slope on this position is 1/8. Okay. If the slope at this point is 1/8, the point slope format is y minus -3 equals to the slope times x minus 1. Okay. That makes sense?
Yeah.
Okay. So y equals to 1/8x minus 1/8 minus 3. That's it. Does that make sense? Oh,
Yes.
25. 25. Here is also minus. 25. Okay. Right. This is minus, this is minus. So this is negative of this guy minus 24/8, which is -25.
Yeah.
Okay. Last question. Find the coordinates of the points on the curve where the line tangent to the curve is vertical. So they ask us to find out any points on this curve so that the tangent line is vertical. So we want to see, look at this. This slope is not vertical. This slope is not vertical. But if we have place like here or here, the tangent line might be vertical, right?
Yes.
So it's probably those locations. All right. That makes sense?
Yeah.
So let's find out those locations. If you want to make your tangent line to be vertical, that means your derivative is going to be non-exist, right?
Yeah.
We are looking for the position where the tangent line is vertical. In another way, saying this guy does not exist. So that means 3y squared plus 2y minus 5 equals to 0, right?
Mm-hmm.
Yeah, now we want to solve this one. So this means y minus 1 times 3y plus 5 equals to 0. In another way, it's saying y equals to 1 or y equals to negative 5 over 3. Okay. All right. So probably this guy over here, y equals negative 5 over 3, and here y equals to 1. So we want to plug in back to the original equation is that guy. Y cube. Would you please read that function to me? Y cube plus y squared, right?
Yeah. Oh.
And minus 5y minus x squared, correct?
Yes.
Equals to negative 4. Okay. Now, when y equals to 1, so this is 2 minus 5 is negative 3. Negative 3 plus 4 is 1. 1 equals to x squared. So x equals to 1 or negative 1, right?
Yeah.
Okay. So that 2 points is 1, 1, or negative 1, 1. Okay. Now let's do negative 5 over 3. Negative 5 over 3 cube is negative 125 over 27 plus 25 over 9. And then minus 5 times that, which is plus 25 over 3 minus x squared equals to negative 4. Okay. So if I do everybody to be 27, if this guy becomes to 27, that becomes 75. This guy becomes to 27. Hold on, I'm not going to. Okay, yeah. So 25 times 9. 25 times 9. 135. So this guy means 27 and 220. 21. Okay. $210 minus 125 minus x squared equals to negative 4. So this gave you 85, right?
Yeah.
85 over 27 minus x squared equals to negative 4. So x squared is equals to 85 over 27 plus 4, right?
Yes.
27 times 4. 108. Okay. 108 plus 85 equals to 194, 193. Yes.
Mm-hmm.
So x is going to be equals to plus or minus square root 193 over 27. Okay, this is going to be a irrational number. So that 2 points is positive 193 over 27, comma, the y equals to negative 5 over 3. Or we have a negative like this. Now let's make sure. So the equation, we can draw this equation inside here. Y cube plus y squared minus 5y minus x squared equals to negative 4. Okay, you see here, right?
Uh-huh.
Yeah, I'm just verifying our answer if it's correct. This point, we can tell is 1, 1, right? That agrees with what we have here. And then negative 1, 1. And 1 point is here, 3.238. So let's verify if our calculation is correct. So our calculation is square root 193 over 27. Some calculation wrong. Let's double check, okay. Yeah, let's double check. Let's see which part we got the mistake. We make the denominator to be 0. Then this guy is 1, 3, negative 1, 5. Cross multiplication. That means y minus 1 times 3y plus 5 equals 0. So y equals to 1 or y equals to negative 5 over 3. Then y cubed plus y squared minus 5y minus x squared equals to negative 4. No problem. Then y equals to 1. There is no problem for this one. This is easy to calculate. Now let's check over here. This guy cube is negative 125 over 27 plus 25 over 9. That's right, yes?
Mm-hmm.
And here, minus is positive. That's 25 over 3, right?
Yeah.
And then minus x squared equals to negative 4. No problem. Now, this guy is this one. This guy times 3, that's 75. This guy times 9. This guy times 9. Oh, I get calculation wrong over here.
Oh.
You see? That makes sense?
Yes.
Yeah, I have a careless mistake. 225, right?
Yep.
Okay, that's a problem. 225. So everything wrong over here. Now 225. Now here is going to, that means 225 plus 75 is 300, right?
Yeah.
Okay, then 300 minus 125 is 175. Yes,
Mm-hmm.
175. And then x squared equals to 175 plus, that's 175 plus 4. So this guy equals to 175 plus 108, 283. Okay. Yeah. So this guy, if we change this guy to 283, let's check. 283. Yeah, that's the correct answer now.
Okay.
Yeah. This is the way to check the answer. Okay.
Yeah.
Yeah, because those numbers are too big. So we want to verify if the question, we get it correct or not. This is 283. Then this guy is going to be also 283 over 27. Yeah, the problem for this question is it's not possible for us to simplify, right? Okay. Yeah, this is a very typical question. They give you a very complicated equation and they ask you the derivative. So you cannot solve your y equals to fx so that you are not able to use those kind of quotient rule or chain rule. You have to use implicit method first. By using implicit method, you get the first derivative, okay? And with this first derivative result, and they asked you the value, the tangent line. So at this point, it's good that you don't need to solve this polynomial equation. They already give you the x, y value. Then you just plug in this whole thing equals to this, okay? But you make sure you use the point slope format. Point slope format to get the linear function, all right? Yeah. And then the last thing is, they always ask you this kind of question. They ask you, what's the location where the tangent line is horizontal? Usually it's this guy. This guy is easy, they won't ask you, because if you want to make this guy equal 0, x equals 0, this is the only location a derivative equals to 0, right?
Yeah.
So that position. They want to find out the vertical tangent line, so you can visually see it's over here and over here. All right? Yeah, and then you want to find the locations. Yeah, you see, this simple point is okay. This one, the other points is very complicated. We have to solve it very carefully.
Yeah.
All right. I believe in their quiz or test, they will give you those kind of questions. Okay.
Is related rates hard?
Related rates, I teach you a little bit about related rates. I'm going to give you a worksheet that I did for the related rates, okay?
Okay.
Your school already teach the related rates or not?
No, it's the next thing you're going to teach.
Okay, yeah, we can do this. We can do the related rates next class.
Okay.
All right, we still have time to finish the related rates before your school test you, okay?
Yeah.
Okay, related rates is exactly those optimization questions in pre-calculus. Does that make sense?
I think I remember.
Let me show you quickly. It's this. Okay.
Oh, yeah. Oh, okay.
Okay, it's this kind of question. All right.
All right.
Yeah, it's this kind of question. We did those kind of questions with pre-cal before. At that time, we can only use the calculator to graph and find the minimum or maximum point. But with related rates, we are going to solve everything by hand using calculus way.
Okay.
All right?
Right.
Yeah. So this is still implicit method. This is week 5. Yeah, you want to choose this one because you see your calculator is not so that powerful, okay? So you have to.
How much is
Yeah,
what
inspire.
videos?
The other calculator is like $150. All right. Okay, I'm going to put this on your notes, and I will also give you the relative worksheet. All right.
All right. Thank
Okay.
you.
Bye. Bye-bye.